Thank you for coming to our talk, One Infantry to Rule Them All, the Standardizing Multicluster Management. And,
Yes, I'm Corentin Debains. I'm a software engineer at Google. I work on GKE Fleet.
oh, sorry, I did go to that page. And I'm Ryan Zhang. I'm working on Microsoft Azure Fleet. So in this talk, we're going to give you a quick, brief overview of multi-cluster history and the current status. And then we will spend some time describe our new shiny new API called Cluster Infantry /Profile API. And we also are going to give you some live demos. Hope the live guard is treating me good today. And at the end, we are going to ask for help from the community in those future works. Hopefully we can get more help and we can hear more feedbacks from this group. So without further ado, let's start. So if you're here, either you have many clusters. How many of you are actually running multiple clusters? More than one cluster?
Damn. Everyone.
Wow, great. Now here's the real question. How many of you are actually running them together? In a sense that you're not having a whole, just the paths, like just could be CTI into one, into another, and they are all like different types and shapes, but you're actually managing them together. Oh, cool. And how many of you are writing tools to run applications onto multi-clusters? So in a sense that you are not having this deployment to this cluster, to that cluster, but you actually manage them kind of like together. Not bad, great.
Cool. Is there contributors maybe of like Multiqueue or Argo that actually write applications for everyone? OSS for this?
Also cluster managers like Kamada, ClusterNet, OCM, Kueue, Stella, Kueue, something. Okay. We'll see. And if you didn't raise your hand at all, just come here for the Lord of the Rings theme. You wait to the end. We have Easter egg for you. Okay, it all started simple, right? With one applications. Your deployment is running in your one single cluster that works well. But then eventually you realize that you need that application to run onto multiple clusters. And in that case, like Argo, Multiqueue, they all invented their own ways to have a list of clusters. And most likely, currently they are using a list of secrets or some sort of like that. And that still works okay-ish. Not the best practice, but it's okay-ish. And then you have multiple applications, multiple multi-cluster applications sitting there. They both need to manage or utilize a bunch of clusters. So they both, as any software engineers like to do, create their own list of stuff, right? List of their own representation of clusters, right? And then here comes the cluster manager. When you have multiple clusters, you want to have a cluster manager. As I mentioned, there are multiple cluster managers in the open source world and in the cloud provider world. We all want to manage clusters. And in that sense, we are all going to create our own list of clusters. Now we can see the problem is basically everybody is doing the same thing again and again and again, both from the producer side and from the consumer side. So yeah, again, here's just a quick list of the efforts in this community. Like basically, again, everybody is doing their own multi-cluster. So in the CNCF landscape, you can see we have Kueue Fleet. This is kind of new. We are contributing to CNCF in the process of contributing to the CNCF. And then there's OCM, ClusterNet, Kamada, Kueue, Stella, Kueue, Admiral, things like that. And also, that's the cluster manager side. And from the consumer side, for the multi-cluster application side, there's a Kueue. I think how many of you have seen this multi-Kueue going to beta? Yeah, huge announcement with the, I don't know, 2,000 people sitting there.
10,000.
10,000, yeah, 10,000 people. Multi-Kueue, right? And ArgoCD has its application set. Kueue Vela has its multi-cluster stuff. It still has this primary and remote mode. And on top of that, cloud providers also try to help. Basically, that's us. We have GK Cloud, GK Fleet, and the Azure Fleet. So yeah, again, everybody is doing their own multi-cluster. And I'm pretty sure there are tons of developers writing their own scripts, running some servers in their basement. And yeah.
There's as many scripts as there's people in this room.
Yeah, no. Yeah, so now Corentin is going to tell you what's our effort to solve this problem.
Yeah, so as part of sig-multicluster, so this is a sig-multicluster effort. We wanted to bring yet another one, I guess, and standardize them all if possible. So we want a community-backed API to define what that cluster list looks like. So defining the list and also defining the groundwork for tooling to leverage that list. So everyone could start sharing the same tools to either produce those cluster lists or consume them, and whether it's to access the clusters or see where they are or anything like that. So we looked at what was out there. We saw that everyone was naming it differently. So like we couldn't find really a standard or winner there, so we came up with our own. Really, there's an XKCD for this. I mean, bring another standard on top of all the others. Anyway, so we have that cab that's merged. We had a lot of arguments as part of sig-multicluster, and we landed on this definition of ClusterProfile. So it's a CRD that's called ClusterProfile. You can see an example on the right of the screen here. It's pretty simple. It's an object with a display name, so whatever fancy name you want to give to your cluster, a cluster manager if you want to track how this cluster kind of got there, and then the version and a bunch of properties. Properties being maybe the most interesting field here, and we'll get back on this. We had a bunch of arguments on the set of rules for this object. We wanted to keep it simple, but at the same time, figuring out how we would manage it and use it. So we kept it namespaced. That was a pretty important thing for us. That made it much more easy to test and keep it constrained and writing permissions and all that. So namespace was pretty important. We also mapped it to cluster set, which is another concept for sig-multicluster. Please go to sig-multicluster if you're not familiar. And then the properties, we agreed on the properties. The other thing we agreed on is what we didn't want to do. What we didn't want to do is deal with implementation. So this is just an API. It's a CRD definition. We're not writing cluster managers. We're not writing consumers of it. We're just doing the API definition. So we want the community to come with some implementation to support this unified list. So that's one of the non-goal for us. The second non-goal is we didn't want to dig into provisioning. This API reflects the cluster. It's kind of a pointer to a cluster, if you will. It is not the cluster itself. It's not the cluster object, and it is not aimed to create the cluster for you. It's a reflection of the cluster after you've created it. So if we go back to our previous picture, now the diagram is a little bit more simple. There's only one list, so we've effectively unified them all, hopefully. So that's the cluster profile at work. To simplify even more, because that's how we're going to talk about it, let's remove the right part. You can imagine there's a cluster profile, there's a cluster for it. And this is how we're going to show usually the cluster profile is like a producer on the left, a cluster manager, produces a cluster profile, and on the right you've got some consumers of it, the multi-cluster applications. And now let's look what this is in practice. Let's leverage the cluster profile. So let's focus on the producer side of it. And here we're just listing a couple. I mean, we're working on GKE and Azure, so we'll have support for cluster profile. We already have fleets, but we want to translate them in the cluster profile so they can be easily supported via open source applications. So that's that. But if you have your own custom cluster manager, hey, write the cluster profile. That shouldn't be too bad. So let's look actually how Azure does it.
Cool. Thank you very much, Corentin. Yeah, so we're going to show this demo is about a Kueue Fleet. Kueue Fleet is the open source project that is behind Azure Fleet Manager. And this PR just got merged. Actually, this is the PR got merged 2 days ago. Yay. Now we are officially having this in the repo. Then I'll do a demo for you. Let's see. Oops. How do I find? No, just go there. Yeah. Okay, let me see if I still have everything ready. So this is I set it up a fleet, but that's an open source fleet. So I'm now pointing to, let's see. So I'm pointing to my upstream hub. Basically, this is a management cluster, manager cluster, control plane cluster. And let's see how many cluster does it have. Okay, so it has one cluster joined. Basically, this is what cluster is joined. And then let's see, cluster profile. Okay, now we have this one. This was, I think I joined that 40 minutes ago. And let's take a look what it has. So here you can see that it has the, I don't know, can you see that? Do I need to, let me just zoom in a little bit more. Hopefully those in the back can see better. That's kind of the most I can zoom. So you can see here, there is the spec is we have cluster manager with Kueue fleet. We have labels, Kueue fleet, and the condition says the API server is healthy. Right, this is kind of what we have now. Now let me join another cluster. Just let me make sure I have the context. Config. Okay, this is pointing the hub. So I have 1, 2, 3. Let me join a bunch of them. Let's see. I'm optimistic. Okay, let's join like 3 of them. This is a script. Basically, it's an open source one. Same thing. Most of open source projects using a secret. So basically, grab a secret from the service token secret from the hub and put it into the member cluster. And now let's see. How many do we have? Oh, no, we start to have. I think I joined 2 and 3 and 4, right? Where's number 4? Ooh. Oh, number 4 is coming. Okay, cool. Let's take a look at number 4. Okay, but I think it's pretty much the same. Oh, currently you can see that the user agent report no status yet because it hasn't really joined yet. It takes some time. In the same time, let me show you. Okay, hopefully it works. Now the second one is joined. Now let me delete one. The second one is joined, right? Oh, that second one. Delete this guy. Then, so basically, this means this is the open source way to unjoin a member cluster from the fleet, and then the cluster profile should also disappear. Yeah. So that's kind of the demo. Now I'll hand back to Corentin.
Yeah, Azure tour. So Azure can publish ClusterProfile. That's really cool. Thanks for merging this PR. Let's look at the right side a little bit. So I mentioned multi-cluster application, reading cluster profiles and trying to get a bunch of them all using the same list. So as examples, I mean, Argo is often the easiest tool to do multi-cluster and the most common, I guess, for us. And multi-queue, I was on stage, so I mean, yay, like, we get it. But any application you can think of, I mean, we mentioned Karma, Kubeadmiral, Kueue, there's a ton of them. But let's talk a little bit how we want to approach them first, because everyone's doing their own thing. So how are we going to convince them to use it, or how are we going to bridge to them? There's kind of 3 approaches we're taking with them, and we're talking directly to all those projects as much as we can, trying to engage discussions. The first way we want to do it is if they have a plugin model, write a plugin that will leverage ClusterProfile directly. That's something Argo does. I don't think it exists just yet, but if someone wants to write it, please. That shouldn't be too hard. A second option has been translation. Imagine the ClusterProfile is written, but you have that other list that your application is leveraging. Well, you just need a little controller that's going to translate the ClusterProfile, read it, dump the other object you need. Simple translation. I'll show an example. I do this with Composition, which is a new little open source tool that the KCC people, the config controller people did. It's a pretty cool little thing when you don't want to write controller in just templates. So easy way. And the last way, which is our end goal, if we can win everything, is everyone leverages the cluster profile directly, and we remove the need for that custom list for everyone. So we really want to get to that last one, but we know it's going to take a long time before we get there. So at least we have 2 alternatives for a lot of those projects. So I wanted to give a little demo on Argo. I put together an entire application. So if we start from the left, I have my fleet. I work on GKE fleets. I have a ton of fleets. So I've leveraged one of my fleets. And I have a tiny syncer that I wrote. I mean, it's really a bash script in a loop. So I open source that if you want it, but I wouldn't recommend it. It writes into ClusterProfile. And then I have a little composition that translates the ClusterProfile into cluster secret for Argo. If you're familiar with Argo, it's entirely declarative for their configuration, or at least the support declarative. So that was a very easy way for me to use that translation method from ClusterProfile to cluster secret. And then to show it all, I have a tiny guestbook application, which is an application set that goes on any workload cluster of my fleet. So let's actually dig in there. That's going to be, how do I get back to the slide? Oh, really? No? Where is it? Whatever, let's get out. All right, so this is my fleet. I'm going to close everything. So it's a simple fleet with a management cluster. I put it in the fleet, and I got 2 members in the fleet. You can see they're registered here. And I got 1 member which is not registered, which is a GKE cluster. I didn't want to create the cluster live because that takes a while. But the cluster is available. It's right there. And on the right-hand side here, I have my 2. So it's one application per cluster, because that's how Argo shows it. It doesn't show application set. Their dashboard doesn't support it. But if I go settings and cluster, we can see my my clusters in there. So this one is like member 1. So that was the first cluster. So let's actually go and register this extra member. So we're adding it to the fleet. So 1 click. Here we go. Okay, that takes a little bit of time, but that happened. So it's the member 3 is now part of the fleet. And if I go here, it may have happened already. No, it hasn't. Great. If that happens too fast, I don't have anything to show you anymore. So let's actually look into my management cluster, what it looks like. Oh, really? Oh, okay, we go. That's live. I mean, you can see we got even the lags. So I got ArgoCD deployed in here, and my cluster profile are living in this namespace, which is named after my GKE project. That's a little convention I use to not get too confused with my fleets. So let's actually look at the cluster profiles. Get cluster profiles minus n. Okay, so we have the 2 members and the management cluster. They had cluster profile. They were there before, so they're already in there. We can look quickly also at the ArgoCD secrets, so you can see what they were what they were translated into. So we have those 2 members here, and obviously my syncer takes forever because it's on the loop somewhere. So let's pop it. You know, the easiest way to get something to sync is to force it the hard way. I'm not necessarily a patient man here. 0, and it's app cluster profile syncer. I think that's how I named it. Nope, that's not how I named it. Damn it. Oh, I know. There you go. Hey, see, second try. So let's just wait, and our cluster profile should arrive. Oh, here you go, 26 seconds. So, see, I needed to nudge it. So it just arrived. So let's actually go back to our ArgoCD. Oh, here we go. Well, I just got my ArgoCD to go there. So it was the whole thing.
Demo.
Yeah, the beauty of live demo, you get lag. That's what you get. So if we go back here, that was the whole thing. I added a cluster to my fleet. It was synced into ClusterProfile, translated to an Argo secret. Argo reacted my application set and deployed the extra application. Obviously, cluster comes and go. That would react. That's the whole point of this. So, just cluster profiles. All right.
Hope you enjoy those live demos and hold your breath when we delete our part.
It's a good namespace, really.
Yeah. Okay, so yeah, you've seen the demo, and now here's the real future work, right? That's how we get to the real one inventory, rule them all. So the first obstacle we are facing now is the authentication and authorization part. So for authentication part, there's mostly 3 ways in our CAP. The first is what is not following the order. The order is here. Like the first is what we use C. Basically, we use secrets. Argo needs one. Multicluster needs one. Pretty much everybody needs one. But if you go to the sig off or sig security, whoever you talk to them, it's not going to be blessed by them. So what we also would not recommend this way. What we recommend is 2 ways. One is the pool model. The pool model means instead of having your control plane basically holds everybody's secret and get compromised and your whole fleet is gone, you actually have this other way around, that your member clusters actually having a way to talk to your hub clusters. And then we have a work API that is also sponsored by the sig-multicluster that have a kind of standard way for the workload cluster to grab work from the control plane and apply that and make it work. So we can use that so that I can avoid this secret pollution there. Another way is also a pretty standard way in the push model without any secrets, that you need to set up your OIDC issuer and then utilize the workload identity federations so that your token on your control plane can actually be authorized to authenticate it onto your member clusters, or workload clusters, and without requiring you store a long-term secret somewhere in your control plane. So these are the 3 ways we want to integrate. And on top of that, after you have the authentication, you still need the authorization, right? Even if your token doesn't have any secret, you also do not want that token to be pretty much a cluster admin that can do anything on that member cluster. So you actually want your application have certain RBAC rules applied to that. But currently, if you look at our ClusterProfile API on the right, I put it here, we don't actually have a way to specify that. So we are working in a SIG to trying to define this process, make sure that we still have the kind of standard way to do that. So that's another area that we would like more input from the community and more help there. And the next thing is, I think Corentin alluded to earlier was, again, if you look at currently that ClusterProfile, it actually kind of have a bare bones CRDs, but the real power is in the properties, right? When the whole purpose of this ClusterProfile is for the other applications to use it. But for the applications to use it, they need to know what kind of cluster this ClusterProfile is representing. For example, you want to have health signals if the cluster is healthy. A few common characteristics is like locations or regions, its type, whether it's a product or staging or canary type of clusters. And of course, we cannot miss that. The theme of this whole world is GPUs, right? You need to know what kind of GPUs you have and how much does that cost. And to use that, we can also leverage another sig-multicluster API called About API, which is serving quite similar purpose, but that API is sitting on those member clusters. It's not sitting in the control plane. So you do not have this single panel glass, whatever you call it, to have a clear view of every clusters, but that we can actually pull these, unify these 2 APIs to support the same standard properties. Now, again, if you have ever worked in SIG, you know that we spent 3 months on a name and another 3 months on namespaces versus cluster scope. So we would like more data inputs to join the sig-multicluster to decide what are the standard properties everybody needs to support, and what are the I think it's what are the core properties that everybody needs to support. What are the standard that if you support, it has to conform to something, and then the extension that is the Wild West. You can define your own stuff, right? And yeah, again, the theme is kind of work with the sig-multicluster. On the fan side, basically, is the producer side. we already demoed GKE and AKS have supporting that. We would like to have more cluster managers to support that, other open source projects to support this, and we will have more proper cloud provider integrations in the near future. And for the fan-out part, we need hopefully for one inventory to rule them all, we need all of them to come into our kingdom, right? So we would like to have more cluster manager, multi-cluster applications that need to look at the clusters, integrate with us. We have multi-cluster SIG meetings every 2 weeks, and we might have
Tuesdays.
We may add in more meetings that just for the community, right? We can help. And finally, for those who are still waiting for the Easter egg, here you go.
Yes, thank you. Questions? Well,
I think there are mics there.
There's a mic if anyone, or screen.
Do you support Azure Arc? Azure
Oh.
Arc will support this.
Okay, that's a good question. It's more of a production question. Yeah, definitely on the roadmap. But for the Kueue fleet, it is open source. You can now Helm install it right now and try it first.
So I came in a little late, so forgive me if I missed this, but is there a custom controller that you have to install into the cluster to enable these resources like ClusterProfile, et cetera?
ClusterProfile by itself is just a CRD, so there's really an API. Now, how you want the cluster profiles to get there, it will depend on where your clusters live and how you manage them. So either if you're using a cloud provider, you'll likely have a solution already existing, either from the cloud directly or that you can install. If you're managing them, I don't know, Terraform something, you'll have to do it yourself, write a controller. So it depends here.
Okay.
sig-multicluster, we're trying to do more of an API and aligning on the API and let implementations flourish, and I'm sure the community will align, I think, on the
Okay,
implementation.
thank you.
sig-multicluster, there is also a cluster inventory API. Can you clarify the relationship between cluster inventory API and this API? Because I saw a document in sig-multicluster that shows an example. It looks like cluster inventory. It looks very similar to this one. So I'm a little confused now about these two.
Yeah, very, very good question. Yeah, I probably should have clarified that a bit more. So cluster inventory is like an umbrella term for all the APIs that we are going to define. The cluster profile is the first API under that umbrella. And another one we are looking at is that RBAC. I was alluding to that we're defining more APIs that allow the application to define what kind of RBAC rule they want on that member clusters. That's another API we don't even have a name yet. Again, naming is hard. So again, coming back is cluster inventory is an umbrella term and cluster profile API is its concrete name. And we will have more APIs under that umbrella.
Yeah, I had a question on the kind of the about API and the ClusterProfile API. Like some of the properties would probably be like static, like the amount of CPU or memory resources that are like allocated or available on the cluster. Is there any sense of wanting to do like more dynamic, like if you wanted to have real-time like information that you could do, then scheduling across, like trying to pick a workload or a cluster for a certain workload?
Definitely, that's the whole purpose, yeah. But the key is we want to define, as you said, what are the dynamic resources or properties we want to make it standard. Key is standard. Everybody can throw them in their own property. But key is from the sig-multicluster part, we want to make sure it's a community standard that everybody want to support. For example, maybe the allocatable CPUs, that's an easy one. But again, if you get into GPU, it's different. Everybody has their own SKUs, different types. How do you define that? I think, again, we welcome more input from the real use cases. That would be very helpful.
It's definitely adding a lot of complexity as soon as you need to refresh, right? Also, we're talking about health, and like health has 15 different meanings, right? Depending on what you mean. Static fields will be a lot easier, dynamic, and then The refresh and all will get more complicated, so that's something we need to continue to explore and see what the community aligns here on usage. Worst case, you can always go query the about API also. It's a little bit more annoying, but you can always access it since you have access to the clusters.
Hey there. So I'm not really a great engineer, and I don't know if I should participate in creating APIs, but I do run a platform team where I'm interested in kind of like the use cases that y'all are building this for. Just to be clear, like, what do I need to do to help make sure that this thing that you're building works for me?
I didn't get the last part.
Like, what do I need to do? I need to join, I'm just kind of intimidated. And if I join sig-multicluster meetings, like, there's all these smart people there. Like, what can I do as a, dumb product manager to help drive?
No, come to sig-multicluster or come to the Slack. Just tell us what you're trying to do. There's a lot of people trying to figure out multi-cluster. I mean, we are still trying to figure out multi-cluster, honestly. This is one brick. Let's add a bunch of bricks together. We can look at your particular example. Figure out.
So I could come to the meetings and just give you a list of CUJs? Is that, like, this is what I want?
Yeah.
Awesome. Thank you.
Yeah. Practically, yeah. Okay.
All right.
Thank you very much.
Thank you, everyone.